हेलो गाइस, वेलकम टू एब्जेंटिव मेंटरिंग स्टूडियो। अब मैथ्स आपको नहीं रुलाएगा क्योंकि आपके पास आ गया है आयुष शर्मा। तो जल्दी से कर दो सब्सक्राइब, लाइक, कमेंट और शेयर।
Hey guys, in this video we will be discussing the first chapter of physics of class 11, that is Introduction to Vector. So we will be discussing the base and the concept of vectors, and we will be just starting from the grassroots level because this will be the base for your JEE preparation as well as class 11 and 12th physics. So we must do it properly and from the basic level so that everyone gets it. So first we'll be knowing about physical quantity. What is a physical quantity? Because any quantity that we measure is a physical quantity. So physical quantity is any quantity which can be measured is physical quantity. Okay, so what are the physical quantity? Let us take some example. Like we can calculate force, we can calculate or measure force, we can measure the speed, we can measure momentum, we can measure mass, we can measure weight. This all are types of physical quantity, and we have mainly three kinds of physical quantities, and we will be discussing one of them, that will be vector. So physical quantity can be classified into three kinds. Let us classify those. So physical quantity are classified basically into three types. First is scalar, that we have been reading since many classes. Second is vector, and third one is a quantity that can be called pure ratio quantity. Pure ratio. Okay, we will be discussing about scalar, vector and pure ratio briefly just now, and then we'll start with vectors. Okay, so scalar quantity are those quantity, we have to be brief and we have to be to the point. Okay, so I'll be classifying in the definition of scalar quantity into 3 points. First, any quantity any quantity with magnitude but no direction. Okay, and second point, they are treated as numbers and follows simple algebra. Means for addition, for subtraction, for multiplication, scalar quantity generally uses simple algebra like 1 plus 1 is 2 only, but in vectors that is not. And third point will be our some examples, like we can say mass, it has magnitude but no time, distance, etc. Okay, so scalar quantity is any quantity with magnitude but no direction, and they are treated as numbers and follow simple algebra. Example, mass, time, distance, etc. Now we'll be discussing what about vectors. So vector is any quantity that has both magnitude as well as directions. Okay, any quantity has both magnitude as well as direction is called vector quantity. Second, they do not follow simple algebra. Okay, so vectors do not follow simple law of algebra. We have different laws of addition, different laws of subtraction, different laws of multiplication, and division usually is not defined in vector. Means we do not divide any vector with another vector. We can add, we can subtract, we can multiply, but there is no funda for division in vector. Okay, and we can take example like acceleration, we can take example displacement, and many more like force. And now let us talk about pure ratio. Okay, so pure ratio are just just the ratio of any two quantity, ratio of any two quantity. We often call this as unitless unitless quantity. Okay, we have read in class 9 relative density. In class 10 we have read refractive index. So this things like relative density is often it means density of a substance divided by density of water at 4 degrees C, which means this is the density of substance by density of water at 4 degrees C, which in which when we'll write meter we will write the density unit, that is gram per centimeter cube, or you can write kg per meter cube, and downside also density will be same, kg per meter cube. So the unit will get cancel out and we'll get a simple ratio. So pure ratio are the quantity which is just defined as the ratio of any two quantity, and thus it is called unitless quantity because it does not have any quantity. And we have example relative density, refractive index. So we have seen scalar quantity, vector quantity, and pure ratio. So let's revise once. Scalar quantity are those quantity which only have magnitude but no direction. Scalar quantity are treated generally as numbers and follow simple algebra. Example: mass, time, distance, etc. Then we have vector. Any quantity that has both magnitude and direction is called a vector quantity, and they do not follow simple algebra. They have different laws of vectors. Example: acceleration, displacement, etc. Then we have pure ratio. The quantity which is just defined as the ratio of any two quantity is called pure ratio quantity. It is a unitless quantity because it is defined as ratio, and ratio does not have any unit. And example is relative density and refractive index. So now let's move on to the representation of vectors and some. So we'll be seeing representation of vector. First, a vector can be represented geometrically, and second, it can be represented symbolically. First, we'll be seeing how we can represent any vector geometrically. So when we will just represent any vector geometrically, we need a line like this with a head like an arrow. Okay, and this can be referred to as a vector. This is a vector. This is geometrical representation of vector, and this part is called as head. This part is called as tail. Okay, and this length is the magnitude of any vector. Means if this is given and the length is given of this is 5 centimeter, means 5 centimeter, 5 is the magnitude of vector. The distance from its tail to head is called the magnitude. Head usually what it refers or direct towards direction of vector. Like we can see this vector direct towards east. First we have to see that we will be seeing like this arrows. Okay, north, south, east, west. We can see the arrow is given in the direction of east. So this vectors direct towards east because its direction of head is towards east, and the length of the vector is the magnitude of the vector. So now we will be seeing different types of geometrical representation, with some examples. Like if we have to represent a force of 5 Newton in west direction, so how will we representing? What we'll do, we'll take a line segment, and the length of line segment should be 5 units. Unit depends on you, whatever you take. You can take 1 unit as 1 centimeter, you can take 1 unit as 0.5 centimeter, you can take 1 unit as 2 centimeter. That is your wish. We will be dividing a line segment into 5 units. Which units you need to decide. Like I have taken 3 centimeter unit one. Okay, 3 centimeter. 3, 6, 9, 12, 15. Okay, so I have taken this 1 unit equals to 3 centimeter, and since it is told that the force is directing toward west direction, so our head will be towards west direction. Sorry, like this is like this west direction, our it will be here. So this length will be equal to 5 newton or 5 units, and the direction shown will be west. So in this way we can represent any vector geometrically. Like we can see some other example, like representing 2 newton in north direction. Okay, so north direction will be this, and unit will consider 1 unit equals to 2 centimeter. So this whole will be 2 newton, or we can say 2 unit. Yeah, and this is the pointing towards north direction. Okay, now we'll be seeing the symbolic representation. How can we symbolically represent any vector? Okay, like if we have any vector A, and we any vector A, and we have to represent this symbolically. So when we want to represent any vector symbolically, we have to just put a bar on it. We can put a arrow sign, or it is not mandatory. If we will write like this also, it is considered a vector, mean this quantity A is a vector. Okay, so we have known that how we can represent geometrically. I have shown you like this: direction, head will represent the direction, and the length will represent magnitude. And symbolically we have to just put a bar on the sign, or on the any value. Like we have got 5, force equals to 5. So we need to represent this, so we'll write that this is 5 vector, means force 5 vector. Okay, so now we'll be seeing like if we want to know the magnitude of this, if there is a force vector, there is a vector, and we want to know its magnitude. So what we will do, we'll just put a modulus on this like this. This will denote the magnitude of vector F. This equal to magnitude of vector F. Okay, when we'll put any vector under modulus, we will get the magnitude of vector. And like sometimes in questions we'll be getting like there is no head on the quantity. No head means there is a given like this quantity and there is no head. So this can represent two things: either it will represent a scalar quantity, or quantity, or it will be the magnitude of vector. When there is no head on a vector, on a variable, or on a symbol, this will indicate either that symbol belongs to a scalar quantity, or that symbol is used to denote magnitude of a vector. Okay, now we will be moving ahead towards collinear vector. So now we'll be seeing what is collinear vectors. So collinear, we have read in class 10 what are collinear points. What do we mean by collinear? So collinear means in a same line. Okay, like this 3 points are said to be collinear if they lies on a same line. Okay, now we'll be seeing what are collinear vectors. So we can just derive a definition: those vectors which are in a same line or can be brought in a same line are collinear vectors. Okay, so what do we mean by this? Like this line is clear that those vectors which are in a same line, but what does mean that can be brought in a same line? Okay, so we'll be seeing with an small illustration. Okay, like we have a vector like this which is directing toward east and the value is 5 Newton, and this is another which is of 6 Newton. This both are collinear. How we can say that? We have seen collinear vector are those vectors which lie in same line or can be brought. So this are not on the same line, this, but there is a function, or we can say there is a rule that when we shift any vector parallelly to it, it does not changes in magnitudes and direction. Like if we have something like this and this, and we want to move it parallel, so we can move either like this, we can move this to this place, or we can move this to place. If this was a vector and we have moved this parallelly this side or parallelly this side, this way means that this vector does not change its direction or magnitude, means the vector will remain same with same magnitude and same direction. So when we want to make this point to collinear, what we'll do, just we'll shift this parallel, or we can shift this parallel to this. So this will become like this, 6 Newton and 5 Newton. They have become collinear, and some are to already given collinear like this, like they are on along the same line, so we need not to bring them in the same line. So this we can say that they are collinear vectors. Now we will be reading something about like vectors, unlike vectors, and equal vectors or opposite vectors. Okay, so we'll be seeing first about like vectors. Like vectors. So the vectors which have same direction, like we have seen a vector of 6 Newton and vector of 5 Newton, they both point towards same direction, that is east direction. So they both are like vectors, like we have read like fraction and unlike fraction. Then we have unlike vectors. Unlike vectors are those vectors which have opposite direction, which do not have same direction, like if there is vector this and there is another vector this, like this point towards east, this point towards west, this is 6 Newton or this is 7 Newton, whatever, since their direction they point towards different direction, they are unlike vectors. Now we will be reading two more topics that are too small, that is equal vector and opposite vector. So what is equal vector? So equal vector are those vectors with same direction, same magnitude, and same physical quantity, means they represent toward a same physical quantity, like mass and force and displacement cannot be equal vectors, because they represent both a different physical quantity. So like example, we can take, this is a 6 Newton force pointing towards east, and this is also another 6 Newton pointing toward it. So these both can be said equal vectors because they have same direction, that is east, they have same magnitude, that is 6 Newton, and they represent same physical quantity, that is force. They represent same physical quantity, that is force. Okay, and we will be seeing what are opposite vectors or unequal. So opposite vectors are those vectors which will have same magnitude, okay, or same physical quantity, but they will have different, or what we can say, opposite direction. So if there is a force of 6 Newton pointing toward east, and there is another force of 6 Newton which is pointing toward west, so this both can be said as opposite vector, because since they represent same magnitude, that is 6 Newton, they represent same vector, that is force, same physical quantity, that is force, but their direction is opposite. This point towards east and this point towards west, so these are opposite vector. So guys, in next class we will be discussing the vectors law of addition, triangle law of addition, and parallelogram law of addition. So thank you for watching the video. If you have not subscribed my channel, please subscribe it. And